Grade 8 Math, number 8.3a. We're going to talk about the elimination method in this unit. Elimination by adding. The elimination method is another method used to solve a system of linear equations. We used substitution in the last unit. One variable is eliminated by adding or subtracting the two equations from the system to get a single equation in one variable. We write the equations so that they're stacked vertically with the terms like lined up on top of each other, nice and neat. We add or subtract to eliminate either the x or y variable. We simplify to solve for that variable that wasn't eliminated. Then we substitute that value into one of the original equations to solve for the other variable. So we can turn two equations with two variables into one equation with one variable without substitution with this method. We use the addition property, adding equal quantities. So here's our system of equations. We've got x plus y equals 5 and x minus y equals 3. We stack them neatly. See how nice and neat? I've got the x's and the operation signs and the y and the constant numbers, okay? And we just add them. An x and an x, that's two x's, isn't it? So we got 2x. A positive y take away a y, well, doesn't that create a zero pair? So now that's gone. And 5 and 3 makes an 8, so now we have 2x equals 8. See? We used inverse operations here because this is multiplication. We use division, and the 2 divided by 2 gives us our friend, the invisible 1. So we have 1x, and 8 divided by 2 is 4. We know x equals 4. Now, we can substitute the x equals 4 into one of the original equations to find y. So let's use x plus y equals 5. But for the x, we're going to put a 4 there. So 4 plus y equals 5. Well, we know that's a 1. That's like first grade math, isn't it? But we have to do it the right way. We have to use the inverse operations, the properties of equality. So we're going to take 4 away from each side of the equation. That creates a zero pair. 5 take away 4 is 1. Y equals 1. Our solution is 4, 1. See? That's our ordered pair. Okay, you want to try it again? All right. So, just so you know, we're not going to do it in this equation, but we will be doing it coming up probably. This is FYI for your information. Sometimes when we see the equations and they're not in the same form, these were nice because they were both almost identical. Well, when they're not in the same form, the terms don't line up. So we can rewrite one or both into the standard form like this, so they do line up, okay? Or you could even write it like this, but this is the preferred method, okay? You write them in standard form, so they do line up. So now we have this one, and these two do line up, so we don't have to rewrite them. We've got 6x plus 5y equals 4, and negative 6x plus 7y equals 20. We stack them nice and straight, see? So that we can see what we're doing. And the positive 6x take away 6x makes a zero pair, so that's gone. And 5y and 7y, well, that makes 12y, and the 4 and the 20 makes 24. So now we've got 12y equals 24. We can divide to isolate the y. Divide both sides by 12, because that 12y is multiplication. There's our buddy again, the invisible 1. We got 1y, and 24 divided by 12 is 2. So we plug this y equals 2 into one of the equations. So we're going to do the first one, 6x plus 5y equals 4. So instead of 5y, we've got 5, 2, because y equals 2. All right? So now this is our new equation, and that's going to equal 10, isn't it? So we have 6x plus 10 equals 4. So now we just have to do inverse operations like we always have. Subtract 10 from each side. It's going to create a zero pair, right? And 4 take away 10 is a negative 6. Now we have 6x equals negative 6. And we can divide both sides by 6 to make this a 1. So the x is by itself. And negative 6 divided by 6 is a negative 1. Look, we got our pair. Negative 1, 2. Because y is 2 and x is negative 1. That's our ordered pair. Now, we could have used the other equation and substituted the y equals 2 into this one for 7y. It didn't matter which one, as long as one of the original equations. I just chose the first one because it was there. Now, this is our solution, And you know we write it in parentheses. Did you know we can write the solution and we can put it into the regular parentheses like we normally do, and then put it into these braces, and then it's considered a solution set. You're going to do that later on as you get deeper into algebra. But I thought I'd show that to you because you might see that sometime. Maybe even your teacher's making you write it that way so that it's a solution set. It's the set of all the solutions, okay? All right, that's elimination by adding. We're going to continue on forward talking about the elimination method. I'll see you in 8.3b. Bye.